All right. So if I want to add this first problem, I've got 4 separate problems. This is not all one big long problem. All right, we got 4 separate problems. And if I wanted to add the first 2 together, I would simply add the numerators and then put it over the common denominator. I can't reduce anything. So that's all there is to it. Same with the second problem. Whether it's adding or subtracting, okay, the method's the same. 2x minus 10 over common denominator of x minus 5. The only thing here is you want to look to see if I can reduce anything. And the only way I can reduce is by factoring. You put that in parentheses. Factor the numerator, I have 2 times x minus 5 over the denominator. Top is factored, so I can cross off factors, reduce. So that's equal to 2. Right? Third problem, we don't have a common denominator, so we need to find one. In order to find the common denominator, I have to factor. First one's already factored. The second one, all right, can you see what the common denominator might be? X plus 5 and x minus 5. It's actually both of them. Okay? It's kind of like doing this. It's kind of like saying, well, what if I want to add 1/3 plus 5/6? Well, I can't say, because this is 3 times 2. I can't say, well, my common denominator is 3. It won't work. My common denominator is 6. So it's kind of the same thing. So for the first expression, I need the common denominator. And for the second one, I need the common denominator, which I already have. So I'm just going to write 50 up there, because that's already contains the common denominator. But what did I have to multiply the numerator by to get the common denominator? X minus 5. That means I have to multiply the numerator by x minus 5. Because really what I'm doing, an equivalent fraction, is I'm multiplying the bottom by x minus 5 to get that common denominator, right? So I have to multiply the top so I don't change the value. I'm really multiplying by 1. X minus 5 over x minus 5, okay, to get an equivalent fraction. Well, let's clean that up a little bit. My numerator, I'm going to distribute the x. I'll get x squared minus 5x minus 50 over the common denominator of x minus 5, x plus 5. To see if it reduces, factor. So I'm going to factor the numerator, x minus 10, x plus 5, over x minus 5, x plus 5. Okay, do you follow me? The x plus 5's cancel. And I'm left with the 5 here. I'm left with x minus 10 over x minus 5. And I cannot reduce that in any way. X minus 10 over x minus 5 does not reduce at all. Okay, any questions on that? Third one. Fourth one. What do you think the common denominator is there? Yeah. Multiply them by each other. Sure. It's like doing this. It's like saying, well, what if I wanted to add 1/3 plus 1/5? Common denominator is 15, 3 times 5. So it's the same thing there. My common denominator is going to be 3x minus 1 times 2x plus 5 here, and I'll need it here. 3x minus 1, 2x plus 5. What do I have to multiply the first term by to get that common denominator? 2x plus 5, so I'm going to multiply the top by 2x plus 5. And what do I have to multiply the second one by to get the common denominator? 3x minus 1, so I'm going to multiply the top by 3x minus 1. If you get that far, the rest of it should be okay for you. It should be easy. I'm going to distribute. 6x times 2x gives me 12x squared plus 30x minus, I think I'll put this whole thing, 3x minus 1, because it's going to contain the common denominator. I'm not multiplying the denominators together. Minus what? You tell me. Come on, what is it? 12x squared plus, are you sure it's plus 4x? Yeah, me too. Okay, when you subtract, remember that, and you probably learned this, when you learn integers, 7th grade, your teacher probably said, okay, when you subtract, it's like adding the opposite, right? So we're like distributing that negative. You got to be careful when you subtract. So it's minus 4x times 3x and minus 4x times a minus 1. Okay? That's where we get the positive 4x at the end. Okay, and so 12x squared minus 12x squared, they cancel each other out. And I have 30x plus 4x is 34x over the common denominator. 3x minus 1, 3x, 2x. 2x plus 5. Okay. All right. There's nothing else I can do. What do you want to do?
What if you FOILed the denominator and solved?
That's it. I can FOIL. And the answer in the back of the book, it is going to FOIL that. It's going to give you 6x squared. 15 minus 2 is 13x minus 5. But that's all you can do. And remember what I said yesterday, Emma, you can leave this in factored form. It's okay with me. The answer in the back of the book might look like this, but you can't reduce it any further. Okay? All right. And here is something that you may see something like this somewhere as an extra credit. You'll be a little bit more involved with this, but you need to have a strategy. This is a complex fraction. And I want to get rid of the complex fraction. I want to get rid of this thing, this a. How do I get rid of it? Multiply by a, right? I'm going to take each term. I'll multiply this one by a over a. And I'll multiply this one by a over a. Okay? A times 1 is a. On the bottom, a times 1, a, plus what? 1. Sure, the a's will cancel. Plus, 1 times a is a, over a times 1 is a, minus 1. Common denominator is a plus 1, a minus 1. Exactly. And then we can go from there. Does anyone want me to finish that? Yeah?
A question. Basically, couldn't like either one of those terms be 1 plus 1 over a, and then I guess in parentheses negative 1 down?
And bring it off to the top?
Yeah. I mean, just
No.
one of those terms.
You couldn't just put a negative 1 in there.
No, I'm not saying just to make one for the solution,
Oh,
but I mean, as a way of doing it, could you do that as part of the process? So,
I'm not sure. Check it out. I don't think so. I don't think you can do that. But, all right. Here's a problem. If I can find it, I'm going to search through. Whoops. Is that it?
no.
No, that's the one I did before. How would you handle a problem like this? Well, Michelle, what would you do?
Well, first, I would like focus on the division part, and
Focus on the first part?
yeah,
Okay.
rewrite it like 2x minus 10 over x minus 1 divided by x plus 5 over x squared minus 1.
And what I want to do is, because I keep making this mistake, is this is supposed to be a plus. I'm going to make that a plus.
Alright.
Okay? All right. And that's exactly the right thing to do. Simplify that first term first. And I'm going to rewrite now and make it into a multiplication problem. Times reciprocal x minus 1, x plus 1. I'll put that on top over the x plus 5. And all I'm doing is taking care of this first term. So here, when I'm multiplying now, the x plus 5 and the x plus 5 will cancel. The x minus 1 and the x minus 1 will cancel. And all I'm left with is 2 times x plus 1. And I'm going to put this over 1 because I'm dealing with a fraction. Minus 4 over x plus 1. And the common denominator is x plus 1. So I'm going to need another x plus 1 on top, aren't I? Yeah, I can square it. And then minus 4. My answer is 2 times x plus 1 quantity squared minus 4, all over the common denominator. And you would probably want to take that numerator, multiply it out, and try to factor it to see if it can reduce with something in the bottom. You're going to get 2 times x squared plus 2x plus 1, which equals 2x squared plus 4x. That's a minus 4, isn't it? Plus 2 minus 4, negative 2, all over the common denominator. And I can tell you right now, we'll save a little bit of work. This does not factor. Yes?
So since the numerator isn't fractional way, you couldn't cancel out an x plus 1.
That's correct. You mean like right here?
Yeah.
Correct. You cannot factor out that. You can't cancel them out. So if you get homework, and I've given you the odd problems so you can check answers to. 509, 510, 11 through 47, odd problems.